The webinar will please be on the line.
Hello everyone, and welcome you all to the webinar series Insights in Computer Science, hosted by Department of CSE, Amrita School of Engineering, Bengaluru. I'd like to introduce the presenters of today's webinar. For track 1, we have Dr. Amuda, Chairperson, Department of Computer Science and Engineering. Her research interest covers computer vision, soft computing, computational visual attention systems. Dr. Amuda has several publications in reputed journals. Today, she'll be delivering a session titled Explore Insights into Data. We have our next speaker, Dr. Prasanna Kumar, Assistant Professor in the Department of Computer Science and Engineering, Amrita, Bengaluru. Dr. Prasanna Kumar has over 18 years of teaching experience, and his research interest includes data analytics, machine learning, theory of computation. And sir would be delivering a talk titled Data Analytics based on COVID-19. We also have our alumni, Mr. Ganesh Belgur, former computer graphics developer, MPC Film. He's here with us. He'll be talking and sharing his experience of being a part of Disney's The Lion King movie. We also have an alumni, Mr. Apurvanan Sahai, currently pursuing his PhD from La Aquila University. The agenda for today's webinar is as follows. We will be sharing the various MTech programs offered at Amrita, not only in Amrita Bengaluru, but also at our 3 campus, Amrita Bengaluru, Amrita Etimadai, and Amrita Amritapuri campus. So over to Jyotsna.
A warm welcome to all those attending today's webinars. Amrita Vidyapeetham is a university renowned all across the globe due to the tireless efforts and deeds of Mata Amritanande. At Amrita, we offer various programs in engineering and medical sciences. In the engineering field, we have BTech, MTech, PhD programs spread across the 3 campuses, Amritapuri in Kerala, Bangalore in Karnataka, and Coimbatore in Tamil Nadu. Now, why take an MTech at Amrita? We ensure scholarships for all students, about 30 specializations across 3 campuses, dual degree programs, which means an MTech from an Amrita university and an MS from a foreign university in the States, Europe, or Australia. A few of the universities that we partner up with are L'Aquila University in Italy and the UL Lafayette provide a dual degree program, student exchange programs at the University of Aalto in Finland and the University of Twente in Netherlands. We offer fast-track MTech plus PhD in 5 years, internship opportunities not only in India but also internationally, and placements for eligible students. Our rankings are as follows, and last year we added another feather to the cap by getting the Institution of Eminence by the UGC. Our placements and internships are as follows. Our international opportunities include student exchange programs, international internship programs, dual degree programs, worldwide placements, and integrated degree programs. Some of the other universities that we partner up with are as follows. Now the specializations are Amrita. At Bangalore, we have the following 7. At Amritapuri, the following 12. At Coimbatore, the following 16. The lab infrastructure at the departments of CSC are as follows. These are some of the trust area groups or the tag teams at the departments of CSC: Computation Intelligence and Computer Vision, Computer Architecture and HPC, Data Mining, Cloud Computing and Information Security, Human Language Technology, IoT and Networks, and the Robotics.
So let us start with the track 1 by Dr. Amuda, titled Explore Insights into Data. Over to you, ma'am.
Thank you, Nalini.
Ma'am, 1 second. I request all the participants to fill the poll that we have posted. You can find the poll in the chat option. I request all the participants to fill the poll in the chat option. Thank you, ma'am.
A couple of more announcements. A recorded version of this webinar will be made available, and the strategy that we would be following for the question answer session would be like this. Please key in your queries pertaining to every track, and once a track completes, 2 to 3 minutes will be allocated to answer your queries. So over to you, ma'am. Amuda ma'am, you can start.
Yeah, thank you, Nalini. So I just request all the participants to poll, to do your poll so that we get a statistics of how much, in what level you are, whether you're a beginner or intermediate, advanced, and we can orient our presentation towards it. So just wait a few minutes so that I will share my presentation, and then we can continue the session. Okay, as the poll is continuously going on and many people are entering the session, we will start with the session, and on the way we will just, after the end of the session, we will look at what is the poll statistics. So the today's session, can everyone hear me? No. So today's
Yes,
session,
yeah,
fine. Today's session is explore insights into data. So this is, we have, if you have looked at the series, what we have planned over here for today's session, we have 3 speakers, which is who was going to talk on various aspects of data. We are trying to look at this entire webinar series in such a way that you get an idea of how to look at the data and give an exposure of an idea about the different kinds of data. And so what the series has been planned over here is, first I will just give you a very simple use case so that everybody gets comfortable to see the insights into the data. And we will look at the second use case, which will be probably given by the second speaker, Dr. Prasanna Kumar. He'll be looking at the recent trend on COVID data. So how to look at an insight into the COVID data. And the third speaker, which is an Amrita alumni, he'll be a totally different insight into media and entertainment industry. So that is how the entire day's agenda has been planned. So going with the session. So we are part of this group. I'm heading the computational intelligence and computing research in computer vision. So the focus area in which I'm going to talk over here is one of the area which we have been investing, that is called as eye movement research. We specifically look at other areas like healthcare center, healthcare systems, we look at visual sensor networks similar to video analytics or a smart city application. And our core expertise is with respect to computational intelligence, machine learning, and we look forward you to interact with our entire research team. So coming to today's session, it's a very top level understanding of how to look at the data. So the entire journey is towards moving from a very raw data to actionable insights. I'm going to make it very simple for everybody over here, and we are looking at a different version to explain the entire concept. So the simple steps which I try to follow over here is, the first is the use case, and then you have an eye gaze strategy, and then an insight to how to look at the data, and then we have a demo session followed by a question answer session. Can you all hear me?
Yeah, yes, ma'am.
Do you want me to raise my volume?
Yeah, I think some are telling no audio.
Yes, ma'am.
No audio. Huh? Okay. Just a minute. Can you hear me?
Yeah, yes, ma'am.
Huh?
Yes.
It's better, no?
Yeah.
Okay. So let us follow these simple steps. So I have just given like a little flow chart. So this is how I'm going to carry forward the entire session. So it's a general guidelines which everyone can take it across. The first and foremost, what we try to do is you prepare a short list of what you expect to see in the data. So the data can be anything. You can be in any business, in whichever field you're working, you can be part of it. But you should be very familiar with the area in which you're trying to look at over here. And you have to then explore the data, analyze the data, and does it make any sense, doesn't make any sense. Why I'm just rushing through it is I'm just going to concentrate on the first step, how to make a short list of what you expect to see in the data. So going forward, so what business I am. So I'm just trying to look at from the perspective of what I am doing it across. So specifically, I'm in education. So I'm more interested to look at in the business field of related to education. So now with me having my purview with the education, so what I'm interested to look at it, what I'm interested. So you know the current situation, we are having a greater transition moving to digital online learning system from the traditional system. So our classrooms have become, which was like this, has moved on to this system. So this transition has brought in to a new area of trying to understand what am I looking at, how my students are really learning. Yes, I know everybody are really learning, but how do I estimate or how do I identify whether they are learning? So we do online tests, assessments, different forms of do an online Viva, so many other parameters we try to look at it across. So now we wanted to look at it in a totally different perspective, pertaining to our research group. So this is not going to help you across that. I'm going to evaluate the system with respect to a new strategy. The new strategy is closer to our research group's mantra, what we call it as, we are what we see. We are what we see. I try to repeat it again. So this is what we mean. Most of our information, which we get it across, is through our human visual system. That means nothing but our eyes. So 81% of the information is gathered. 81% of the information is gathered through our eye. So we are trying to look at that data as our resource, which is going to help us and understand whether my student is having his learning exercise done properly. So how am I going to do it? So looking at a little more in detail about it, when I wanted to estimate whether a student has learned, whether he has understood any concept, there are many parameters. As a teacher, we know there are many parameters. We wanted to know whether he's paying attention, is processing nicely, whether he's able to analyze, whether his judging capacity is better, his reasoning, problem solving. So there are n number of parameters which we have to comprehend and then tell his learning skill is right. But we don't have that extensive time to analyze every skill. And then we, with this 20 minutes of time duration, which we have, we wanted to look at only one specific aspect, which specific to a computer science learner. We are going to look at how am I going to estimate for a specific person his debugging skill. So specifically, I'm going to look at, there are different aspects with respect to your processing. You have a memory, attention, processing, and workload. I'm specifically looking at whether he's able to recollect something and then he's able to understand, and then he's going to extend it when a test case is given to him. So we are specifically concentrating debugging skill. So looking at my prepare a short list of what you expect to see in the data. My very specific focus over here is I'm going to look at whether there is a debugging skill with my student. So how I'm going to explore? So I'm going to explore, as I told you, I'm going to explore with the data, specific data, and I've put some parameters. We will just go and look at what are those parameters, something called as fixation, scan path, and blinks. So I'm going to introduce now specifically now looking at my definition. My business is education, and I'm going to look at my interest area, my focus areas. I'm more interested in looking at what is the debugging skill of my student. So how I'm going to analyze it? So how do I measure it? Okay, so the data, there are different kinds of data. You would have come across images, videos, text, webs, so many other resources. But what is my data? My data is totally little different, which you have not heard about it. So what is that data? So we are going to get a data from an eye tracking instrument or a sensor. So eye tracking is a sensor technology that enables to know where your eyes are focused. So now you got the point. I'm now going to look at where is my student looking at it. So I'm going to look at and understand what information he's going to look at it. So once I get that information, what he's looking at it, I'll be able to understand whether he's present or his attention is into the learning process, whether he's drowsy, he's conscious. So I'll be able to link between the eye movements and his cognitive information. So this is what I'm going to do. I'm going to constrain my data. So I have fixed my objective. Now I'm fixed to my data. My data is going to be an eye gaze data, and I'm going to measure over here. So I think people who have joined earlier in this lecture, in this webinar series, could have seen a repeated focus of one video continuously being playing. It has been specifically played to just look at one specific concept. So we are introducing this. So this is eye tracker, which you can see. I've paused it over here. This is called as a remote eye tracker, and the one which I've placed over here is an eye tracker which can be placed into the laptop. So what is these two? There are different kinds of eye tracker. We are not going to look at all those details of all these different eye trackers, but I use this as the technology to understand what you're trying to see. And so I'm collecting the information of what you're seeing, whether it's going to be on a 3D world. For example, what is being shown over here, the person is walking on the corridor. If you can look at, I have put my thumb, there is a green spot over here. If I play further, you can just see that as the person is walking, she's looking at the tree, and I can see which information she is looking at. So this information, I get it across. So no, I don't, this is a visualization, what you see in the screen over here, but we don't get the data, I get a raw data. So the raw data, you would have seen many forms of data. Can you make a guess what kind of data it could be? Is it an image, or it's a time series data, or it's a video, whatever it is? It's a very complex data. It's a time series data. Every sample is being related to a 3D field or a 2D field to which it is connected to it. So I will be able to know at time period T where I'm looking at it, which information on my scene I'm looking at it. So now I know, I get an idea from the data. This is what I'm seeing. So now what is my next step? Okay, so now more interesting thing. Can you find a banana peel in the image? I'm sure everybody is able to locate a banana peel found over here, and there is a banana peel found over here. So now I'm just going to look at, you would have traversed this image, and then you would have identified the banana peel. So what we have done is we have done the same experiment. We have shown this image to a participant, and we have recorded his eye gaze movement using the sensor which I showed you now. So let us see how it looks like. Okay, so now if I play over here, you can just see there is some small dots which is appearing. So these are called as fixation. So this is how you've been fixating it. It is now looking at, so you can just see the dots have been continuously moving. Now it goes to a different image. So now again, you see I'm searching across. The dot is the point where I'm searching. So the participant would have been visiting these areas, but not visiting these areas. So these are called as fixation. So these are the points where I've specifically focused and tried to identify whether my interesting object is present or not. But the other one, so now how I moved my eye. So initially I fixed over here, then I move to this and I come back. So I retrace. So this is called as saccade. This is called as eye movement. The movement of your eye when you're perceiving or seeing the image. I'll be able to understand how you're traversed, from where you've started, where you're moved, how is my traversal. So I think this is enough for me to understand whether my student has learned the concept or not learned the concept. So these are the two important parameters which I'm going to look at in my data. So I look at, this is my fixation and the next one is my saccade. So how I'm going to use it across. So I look at a very quick definition of basic eye movements. So you have fixation. So fixation is a point we call as eye is motionless. Information is obtained at fixation. So for example, I focus it, I get immersed into that information, and then I continuously look at for a longer period to get a grasp of it. That is called as fixation. The next one is saccade. Saccade, if you look at it, is a rapid movement of eye. So from one spot to another. So like if you do a reading exercise, you will be moving from your left to your right. So your eye also moves like that. So we call that as a saccade. And then you have third, which is blinks. Blinks is nothing but your shut. Everybody is familiar with it, the shut open of your eyes. But according to the data, we assume that this information, as I'm not going to look at whether a driver is drowsy or not, so I'm just ignoring whether he's closing his eyes or not. So this is, according to me, a data which is not required for me to process further. Maybe I can avoid it. And so the most important thing which I'm going to discuss is fixation and saccade. And further on, when I proceed, I will drop saccade and I will look at only on fixation so that my model becomes very simple and easy for me to convince the entire audience. So my strategy is very clear. So now I'm going to explore eye gaze data. Okay, so once I very clear with what I'm going to do and what kind of data I'm going to analyze, my next goal over here is fixed. How do I analyze the data? Okay, so how do I analyze the data? So I fixed my objective as debugging skill. I fixed my data is going to maybe a wide amount of data is there. I fix it as eye gaze data. And I know I picked up certain parameters, something called as a fixation, a scan path, and a blink. And as I told you, I'm not going to use all those parameters. But how do I analyze the data? Okay, so generally analyzing the data is making plots, summary, trying to identify whether what is my criteria, how to fix it across. So what I'm going to do is, I'm not going to go to the technical details of all the design. I'm just going to analyze the eye gaze data. So I assume that I have an eye gaze data with me. And I'm going to introduce the terminology, which I'm going to continue in the further session. I'm going to identify something called as area of interest. And then I'm going to define something called as a hypothesis. Is my dwell time proportional to debugging skill? So before going to understand all these terminologies, I will just let me explain you what is my setup. Okay. So this is my setup. So remembering that we are going to identify the debugging skill of the students. What was the exercise we followed over here is we introduced this as when we do a first year C programming course to the student, we gave this small program to identify bug in a given program. So the program statement goes like this: to swap two numbers and print the numbers before and after swapping. So what we do is we ask the students to browse through this program and then identify whether there is an error. So I'm sure I want Aditya to help me across. Is the audience is able to identify the bug present in the code? You can put your answers in the chat session so that Aditya can let me know whether you are able to identify the bugs. It is not a very difficult bug. It's a very basic first level bug, which we generally tell it across. Is the audience able to understand? Aditya, can you just let me know? Can you identify bug in the statement, the 18 statement, which I posted over here? Can you see any bug in the statements? Okay, when you're looking at the code, you can spend a little more time. I will just show you how the participant has been viewing the same scene. Okay, so you're scanning parallelly. I will just show you a video for how the participant has been looking at it. So this is how the scan path or the saccade of the person. So he's moved from your header main and then gone to every line of the statement and tried to understand whether there is a bug in the system. So this is the process he's been doing it across. So okay, so I just do it across so that you understand. So we have recorded the eye gaze movement when the student is sitting before the program and then trying to analyze and understand, is there a bug in the system? Okay, and we have recorded and this is what we are playing it across. So if somebody has identified the error?
I see a couple of comments in the chat box, ma'am. It says line 10 and 11 does not have %D.
Yeah, right.
And there is also another comment which says there is ampersand in the printf statement.
Okay,
ampersand in the another reply which says return type. So these are the few comments I see in the chat box.
Okay, so we just take the there's an error over here which we have tried to analyze over here is the error which is in the scanf and the printf statement for further processing. So we have done the end-to-end analysis on having a missing ampersand and a missing %D window as a bug. So now how are we going to investigate on it? Okay, so this is another visualization. As I told you, we make different plots. So the one plot is the saccade plot, trying to look at how was your eye gaze movement when you're looking at the image. This is called as a heat map. Okay, heat map is nothing but where was your focus? Okay, where was your focus? So this participant, if you look at, this is the area. So you can just see there's a red region. So he has spent enough amount of time on this region, and we call this as a dwell time. Okay, how much he has dwelled, how much time he has spent in that specific area. So here it's a little lesser shade than the red color over here. So it indicates that he has spent little lesser time over here. And these areas where it's all completely white and no coloring is being shown, it assumes there was not much of eyes movement in that, or you're not visited that areas at all. So this is how is the region in which you have looked at the entire program. So now what I'm going to do with this entire system, so I'm just made a simple model for me to go ahead with my understanding of it. So he is my student, he is my learner, I have my eye tracker fixed, I have the program here which is displayed. So what he's going to do is he's just going to look at the program, and this eye tracker will give me the data, which is called as a raw eye movement data. I extract these features, which I called as fixation, saccades, and blinks, and then I do the entire analysis to identify whether he is a skilled person, he's able to do a better debugging or whatever it is. More specifically, what I'm trying to do over here is, now I'm going to predict the debugging skill of a learner. So not going to the technique of details of how I'm going to do it. The process a simplified process of what we actually followed, I'm presenting over here. So the learner, when he is looking at the program, we have been asking him to tell how many errors. For as I asked you, what was the error? We asked the learner also to tell how many errors you have identified. We call that process as a think aloud process. So we record the bugs made or how many errors you identified by the learner. And as I know, this is eye gaze data. And what I'm going to do over here is I'm going to identify, as I showed you in the previous slide over here, this is my bug area. I'm going to tell that is my area of interest. So I wanted to know whether the student has visited that particular region, area of interest, and has he spent quality amount of time to investigate and identify the error. So we call that, as I discussed, it's called as dwell time. So I'm going to calculate what is the dwell time of the participant in that area of interest. So I have these two information. So I just try to model a system which might try to tell whether he is able to, he's good in debugging, or he is identified and he's a skilled one, or he's an expert, or is not an expert. So quickly, so now I fixed the third part of my process, that's analyze the data. So I fixed an area of interest, Okay, the area of interest is my error. And I have looked at the parameters, and specifically I'm looking at dwell time. So now my hypothesis, I'm going to look at whether my dwell time is proportional to debugging skill. So I'm just going to look at whether my dwell time, he was going to spend more time over here, whether it's going to be reflected, and I can tell, yes, he is a good in debugging, and it is correlating with something which I called as he's a skilled person or he's not yet learned this debugging skill. So I'm going to look at, does it makes any sense with my expectation? So I'm going to look at whether this parameter has got any connectivity with what is called as this debugging skill. So this is a quick general outlay. We will not discuss in detail. So you have, when we classified and looked at, we looked at an unskilled person who's not had a scan path, where he's not even spending enough time on his entire code. A skilled person has been looking at like this, and an expert has been spending carefully on every line of code, and we call this as a code coverage. So we can very clearly look at the visibility of, we can find the difference across all the three different categories which we have put it across. So what we are going to do over here is, we are going to just look at specific cases which so that look to closely investigate how was the pattern. So the case one over here is, so this skill over here is, so this is a scan pattern of this person, and this is his heat. So he is assumed to be a person, okay, who has got a larger dwell time. Okay, if you can closely look at the figures, very small over here, it is somewhere 61, and he's able to detect the detection accuracy, it is written 2 over here, so he's able to identify, and he can be very focused, and this is what this, so he has spent enough time in the area of interest. So you can assume that he has spent a quality amount of time, so it's proportional, and I immediately identify his dwell time is high, the number of bugs detection defect detection accuracy is high, and then I immediately identify him as a skilled one. So what I've done is, I've looked at his dwell time only in this area, not in the rest of the area, because my specific objective is only trying to look at whether he's identified the bug. So in this area of interest, look at the dwell time and then define a system. This is quickly for this model we have built for this specific session alone, and identify the defect. I mean, not identify the defect, identify whether I can label him as a skilled. Similarly, we will look at, so my fourth criteria, does it make sense? Okay, so yes, it makes sense, because dwell time seems to be proportional to the debugging skill. So I can assume, yes, if you spend a quality time in my area of interest, and if I'm able to measure the dwell time, and it becomes in one of the indicator, and I can very well tell he has gained it across. So now the case 2, which we are trying to propose over here, is you can just very specifically look at the values what we have got over here. The dwell time comparatively is lesser than the previous person, and he has not identified. So when we did a think aloud, ask him to tell, he has not identified any error, even though he has looked at the code very thoroughly. You're not able to do so. We significantly correlate that his dwell time is relatively lesser than what. So we immediately tell, okay, he is not a skilled person. So his dwell time is low, and his number of bugs detected, defect detection accuracy is also low. So I end up telling he's an unskilled person. That means I have to look at more closely and monitor him and try to make sure that he understands the concepts, and then go further about it. So it is not always the case. You may have a case 3 very differently. So the case 3 over here is, the dwell time is similar to the previous case. The dwell time is also less. The defect detection accuracy also is less. So now it is all matching with my correlation, whatever I've tried to tell. But sometimes your data may not make enough sense. That means it may not be always what I have assumed may be right. The dwell time can be more. Okay, the student may not be able to answer. His code coverage may be more, cannot be able to answer. So it means that what you have seen is not enough. Okay, so I have restricted my analysis in a small, what I can tell it as, I have just made it as a I have narrowed down the entire objective and put it into a small, what you can tell as a keyhole or whatever it is. I'm trying to see the entire problem through that hole. So when I try to look at, something makes sense, but something doesn't make sense. So when it doesn't make sense, what I should do is I should come back and then look at the entire system in a more better way. So I've been looking at with respect to only a dwell time, okay, how much he's been spending time on it in that error area, but that is not enough. That is not seriously enough. So I should look at other parameters. So other parameters, so that's what is mean. The last one, if your data and your what your assumption is not going to make any sense, that means you have to zoom in, okay, you have to go closer and then look at the insight required for your business. That means it's not clearly indicating whether his debugging skill is right. So what I should do over here is maybe I should look at the other various factors. As I told you, we have other factors like attention, focus, drowsiness, so many other factors. So as I skipped in the initial part, I was looking at fixation. I was looking at only at dwell time, one of the parameter. So now I go further onto it and then look at what is the scan path, code coverage, and then try to understand it more better. That means, so I'm trying to look at the information in more detail so that it will be helpful and give me more relevant insight of how to help my student who is not really able to cope up. So what does he fail? Okay, what is really happening in across? So I'll be able to understand more and then maybe able to help him. Maybe for that test he is not concentrating, he was not paying attention, but he really learns it. So I'll be able to understand more insight into the system. So that's what is the last one makes. So going around the entire flow chart, what I put over here, it can be any XYZ domain you're trying to apply it. You can pick up this as a guideline. Prepare a list. What is your specific objective? So I put it over here. The objective of yours is outcome of the learner skill development. And specifically, I'm just looking at debugging skill, explore the data. What is my data? I have to fix it across what parameters of the data, how I'm going to analyze it. And I should have a hypothesis which supports my intuition of how I'm going to move forward. I can do a machine learning, I can do a big data analytics, I can do anything across, but do I have something related to it? And then look at whether I make any sense with the data, and then further go down and then look at whether I'm making, is it enough what I've done or something else I have to do it more. So now what I um, request you is I just have a small demo session, and it is Ms. Chandrika R. She's a scientist in ABB Bangalore. I'm very happy to tell that she was my colleague, and she did a postgraduate program with Amrita in computer science, and then joined a PhD program under my guardianship and got an internship in ABB and was really absorbed later into permanent position and still continuing in my lab. So I welcome Chandrika to take over and then show us a short demo of what you have been explaining so far.
Yeah, thank you, Amuda ma'am, for introducing me and giving me opportunity to be a part of this webinar. So while I'm sharing my screen, um, yeah, I Aditya, I think I'm not able to share my screen yet.
Okay, okay.
Okay,
Share the desktop option, Chandrika. Try the desktop options.
No. Okay, I'll just try in a different way.
Okay, I can take some question answer session parallelly.
Yeah.
Yes, if you have any questions, you can raise your hands or you can put your question in the chat box. This is to all the participants. You can post your questions in the chat box or raise your hand. We will unmute you.
Aditya, I think I'm not able to connect you. Just give me a minute, maybe.
Yeah.
Desktop sharing option you try, Chandrika.
Okay, I can see somebody raising their hands. Namshinato.
Hello, ma'am.
Yeah.
The
Can you
user is,
introduce yourself? I mean, so that it's easy for us.
my name is Vamsina, and I'm working as a assistant professor in engineering college in Andhra.
Okay.
Ma'am, I have small doubt. User is required a special specs for this
User is required.
to analyze that in front of the computer. User has to sit with a special type of specs.
Yeah. You should have that. What I showed you, no, you should have a remote eye tracker which has to be placed over here. But
Okay.
we assume that it could have been later in your higher end models. It could have been it will be integrated. So you could have just the next generation computers. This eye tracking will be one of the component which may be available for you. But as of now, it is you have to have an external interface. Either you can have a glasses or it can be a remote eye tracker which you can place it below your. I showed you in the pictures. You can place it.
Already the prototype is developed, ma'am. It is in the research manner, the prototype.
Yes, it is. There are two popular companies. There is SMI and Sensor Motoric Instruments, and Tobii is the two players in this eye tracking. And then previously we had some low cost eye tracking which is available, but that is now recently acquired by Facebook and Google. So, but I think there are quite a amount of number of players, but currently we don't find people who have been developing low cost eye tracker. I think the two eye tracker which was commonly available has been taken over by these giants.
Share the screen.
Okay, man. Thank you, man. Thank you. Thank you.
Anyone else? I think someone else, Kumara Velan. I think it's Aditya. Can you ask someone? I mean, somebody has raised their hand. Kumara Velan. Whoever is it? G. Kumara Velan. Can
G.
unmute?
You can speak right now. I have unmuted you. I think there is a connectivity issue now. There is one more question in the chat box from Kavya.
Okay.
She is asking, is heat mapping, like the heat mapping is raw data that has been mined?
No. The raw data is a very complex data. I think you have to know that the raw data, we can process it across, but and if you wanted to get the information very clear, I think we should do a cleaning process. So we do a lot of cleaning of what we wanted across, what information we really wanted, and then only process. So it's a process data. It's not a directly raw data which is to be done. But any visualization technique will work, but the information will not be clear. So that's the difference. But whatever information we have given over here is all processed data. Is that fine, or you want some more explanation on that?
And she asks, what is the tool used for analysis?
Okay, so as I told, we have eye tracking lab. We have a hardware and a software package which is available, licensed for us to analyze the data. But we have been using open source tools. There's a Python open source eye gaze data analytics open source functions which is available specifically to identify specific features on your eye tracking data. And then there is an Ogama platform which is available. So there are quite a amount of open source platforms, and we have been working in all those platforms.
Chandrika, are you able to share it or?
I think let's move on to the next track.
Okay, fine. I
taking-
think then I will just wind up. Um,
Yes, ma'am. Yes, ma'am.
okay.
I think
So
have
Nalini, I will try to, because my screen is not getting shared, so I'll try what is going on. By then, I think the next speaker
Yeah.
can take the role, and maybe at last we can give the demo.
sure.
Okay.
Thank you.
Okay. Thank you, Chandrika.
Thank you, ma'am.
So this is people who are interested to look at more about um, what we have been discussing across. We have a quite amount of publications specific to the topic what we have discussed over here. So please, interested people can just look at these research publications. And this is not the one. This is not the field which we are working. Is one of the field and one of the application we are doing it across. We have nearly 8 PhD research scholars who are working in and around of this field. So um, so these are the quite bigger field of which eye gaze data analytics has been applied: vehicle interface design, understanding the drivers, understanding for security, social interaction on surgeries, consumer research. So there are quite amount of applications. So it's not the end; it's the beginning. So please go ahead and explore what is available and how to get a better insight onto this eye gaze data. Since we have done with the queries, I just move on to my thank you slide. Thanks for joining. Thanks for the organizer for giving me a chance. I welcome each one of the participants to be in Amrita to explore in whatever form you can do. You can be a visitor, you can collaborate with us, you can join our MTech program, do an internship. Welcome to Amrita. Thank you. I will just introduce the next speaker of the day. It's Dr. Prasanna Kumar. He's my colleague. He's assistant professor, computer science and engineering, Amrita School of Engineering, Bengaluru. And I really, as I told, introduced, I have taken a very small use case and I've made it very simple, telling that with respect to students, I've given him a bigger task of looking at COVID-19 data set and then give an insight to it. So I've given the challenge to Dr. Prasanna Kumar, and I'm sure he will continue the session and give an insight to it. Over to you, Prasanna Kumar.
Yeah, thank you, ma'am. I hope I'm audible to all, right?
Yes, sir.
Okay. Fine. So good evening. Thank you to each and every one of you for joining with us today. We are very pleased to be able to welcome those of you for this webinar. On behalf of Amrita School of Engineering, I'd like to welcome you today for the session on data analysis on COVID-19 data and Indian perspective. So,
Sir, I think
yes,
we are not able to see the PPT.
You didn't share, I think.
Okay.
So.
Yeah, I think it's visible now, ma'am.
Yeah, fine, sir.
Okay. So I'm Dr. Prasanna Kumar. I'm working as a faculty in the Department of Computer Science and Engineering, Amrita School of Engineering, Bengaluru, Amrita Vishwavidyapeetham. So my talk this evening is divided into two main sections. First, let's have a presentation about SIR, a time series model, where S is susceptible, I for infected, and R for recovered. It's a time series model, and we just move on with that. And once that presentation is over, I'd like to show a very small demo on how visualization can be done with time series data. So just before getting into things, I'd like to set my agenda. So we'll be discussing about 4 things here in this presentation. The first one is about data, that is the data set that is under consideration here. And we are going to discuss about the method in which the data is analyzed. So the first method, as I told you, is SAR. SAR stands for the susceptible, infected, and recovered model. And an advanced version here with respect to, particularly with respect to COVID model, is this SAR-F with exposed waiting cases. And finally, we'll have a case study based on India data, and of course, the agenda or the references. So let's just get into things. And here, before getting into the data set, I'd like to say what is time series analysis and what are the things that are done in time series, right? So here, time series analysis is nothing but it's a process which varies over time. That is, it's a continuous time process. So a recording a recording of a data can either be continuous, or a set of discrete observations. Sometimes it may be stationary, sometimes it may be moving, sometimes it may be volatile, etc. So based on that, we can go for some forecasting. So forecasting here refers to, on the basis of observations that we have done, maybe based on the number of days, day 1, day 2, day 3, etc. We may wish to predict what values can be for tomorrow, or maybe for next month, or maybe for the next year, and possibly to give an indication of what the uncertainty is in this prediction. Okay. So just coming into the data set, which we are going to see particularly for the visualization, is from the Johns Hopkins University Center for Systems Science and Engineering, that is JHUCSSE. Okay, worldwide, all the countries are using this particular data set for their reference. And in particular, we are interested in 3 files in this. There are 5 CSV files in this particular data set, and we are interested in 3. One is the confirmed global cases. The second one is the confirmed deaths, sorry, not confirmed, actually, it's a deaths across globe, and recovered global data, right? So these are the 3 data sets which we are interested in. And all the 3 are CSV, that is comma separated values. Now, why should we go for analysis? What's quite interesting here? Right, that's very much important, and it's also like interesting to analyze data and just come out with some interesting observations. So actually there are a number of time series models like moving average, autoregression integrated with moving average, and seasonal ARIMA models. Okay, so here what is interesting? See, let's take two classic examples today, one with respect to Iran and other one with respect to Kerala. So this is based on the data which Johns Hopkins University published yesterday. So here, as far as Iran was considered, there were active cases well consistently. That is, the growth rate was negative for weeks, but suddenly you see a positive and a growing rate there. So what does it mean? So it means that the virus doesn't go away when that R naught value, but just discuss what is that R naught and all later, or the countries that flatten the curve actually. So we need to have some long-term management strategies, and this particular forecasting strategies will be helpful for such things. So we'll just use a few slides, that is, we'll discuss about some data analysis done based on the time series model. Okay, so this particular model is done by Professor Shamika Ravi, and I just got that from her. So this particular thing, data source also I have mentioned here. Okay, so you can see that the growth rate, for example, here we just have, sorry. Yeah, so here we have a column which states that which starts with 0. And you can see few interesting things here. One is regarding China. So it has got, it is not at all 0. Even now it has just passed out of the pandemic situation. In the sense, it has totally eradicated that. So another interesting scenario here is that there are a few other countries like that: Japan, Switzerland, Turkey, Italy. Because Italy also, the number of cases are coming down drastically. But let's see the other side. That is the right-hand side of this graph. So in this graph, you can see that countries like India here, okay, we are just progressing in the forward direction, which means that we are high on, that is, the number of cases is getting increased day by day. So next thing is, this is also based on May 16 data. This is, that is some 2 days back. So here you can see that 2 countries, India and Japan, have low and growing steadily. That is, the number of cases are low, but it's growing steadily. And we have a few other cases like they are already high, but still growing, like Belgium, UK, Sweden, US, and Canada. So you can see in this graph that US and all are just at the bottom, which means that they are growing very much rapidly. Okay. So the next graph is called as a pretty graph, in which I think it's not much visible here. Okay, so you can see India here, particularly the number of cases that has been shown every day. Okay, this particular color shows that everyday cases. Okay, but anyway, I'll just show a visualization of this thing later in the presentation, demo part. So based on such analysis part, how countries are recovering. See, countries like Germany, South Korea, and Iran, they are facing the second new wave. So this data is based on data that is the latest one from May 17, that is yesterday. Okay, So countries like Italy, Spain, and they have much lower data, that is actual cases. But few countries like US, UK, Russia, Brazil, and they all just have active cases, and it's really growing very fast. No, nothing is there to stop them. Now let's coming for our perspective, that is India perspective, and this is based on yesterday's data from Johns Hopkins University. So here you can see that the cases, actually this is the actual number of cases here. It stands for something like this. And if this progresses like this, and we have some 7-day, 5-day, and 4-day doubling rates, that is the number of cases doubles every 4-day or 5-day or 7-day, you can see how much the expected value are. See, this is not forecasting, but I'm just telling that if the cases changes like this, then what will be the growth rate? So we are just nearing 1 million now, but soon, if the number of days gets reduced, as of now, our doubling rate is something around 23 days, right? If it just gets reduced to 7 days, it will be something around nearing 3 million. If it gets to 5 days, it will be some 4.1 million, and if it is 4 days, it will be much higher, that is 5, right? Okay. So next, coming to the statistics based on the states, we have few states like Maharashtra, Gujarat was still having very high number of cases. This is also based on yesterday's data. So that is the current available data. And good news is that a few states like Tamil Nadu, they are reporting a declining active cases. See here, it's the active cases, right? Not the number of, what is the total number of reporting cases, but active cases get reduced. Why? Because of the rising recovery rate. Okay. So the next slide is on like we have a 5-day moving average. This is one sort of time series analysis. As I told you in the introduction part, we have few time series models like moving average, auto-regression integrated with moving averages, etc. And this is for this particular graph is based on moving average model, where we have approximately Maharashtra is leading, followed by Tamil Nadu, Gujarat, and Delhi, right? And Rajasthan, Madhya Pradesh, UP, they follow them. Okay. So anyway, I'll be just sharing the slides for your purpose so that you can just zoom these things and see it later. And this is actually based on May 16, that is 1 day before. I was not able to plot the chart for yesterday's data, but anyway. So states like Kerala, Bihar, Gujarat, Rajasthan, Jammu and Kashmir, MP, that is Madhya Pradesh, they are speeding a bit. See, that's what I told. There's an interesting case about Kerala here. So suddenly it saw some 14 cases day before yesterday, that is on 16th. So the model actually predicts that there is a speeding, that is the number of cases rises in this particular state. And what about other states other than this 6? It states that everywhere else it's getting reduced. So some positive news here. Okay. So the next thing is the number of tests conducted. There's a graph here which shows that Maharashtra, Gujarat, and Bihar are not doing up to the mark, and others are somewhat doing, like Orissa and Telangana. They are just doing somewhat, right? Okay. Now, what about the death rate? Okay, the death rate with respect to Gujarat and Maharashtra are 4 times greater than that of the all India rate, and actually only 5 states are driving the total death rate in India. They are West Bengal, Madhya Pradesh, Delhi, Maharashtra, and Gujarat. These 2 states also comes in here. Naturally, it should be the case, right? Okay. So now let me just move into our issue, that is, what is this SAR model? So this SAR model is nothing but, as I told you earlier, S stands for susceptible, that is, it's nothing but all the cases minus the confirmed case. So here all refers to the total population of a particular country, subtracted with that of the confirmed cases. We call it as the susceptible. The second one is infected, which is calculated by confirmed minus recovered minus death. Okay. So in a sense, from the total number of confirmed cases, we have to remove the recovered as well as the deceased person. The last one either refers to recover or recovered or fatal. So recovered in the sense they have just got treated and they just went away. So here stands for here it is added, that is record plus death is added into this R. So that's why we call this as an SAR model. So see, this particular thing, there's a small change. Here this R stands for recovered and have immunity. But here in this particular COVID data where the spreading is entirely different, it's considered as or as recovered as well as fatal here. Why? Because the mortality rate cannot be ignored here. Why? Because it's too huge in other countries. Now, where does this particular SIR model used already? So as per the literature of a secondary data done by Drecci and Wachmau, published in the year 2002, it was actually used in the spring wave. That is, this model, SIR model, was used for predicting by saying for the spring wave of 1918, fall wave, and H2N2 by the US in 1957. Okay, and then SARS in 2002 and 3. And after that, 3 more recent cases have applied this. One is the Zika from South America, that is just some 4 years back. And we have that Ebola from 6 years back, and H1N1 in the year 2009. So all these things, they use this SAR model to calculate that. Now let's just move to this model and let's discuss how this SAR works. So here this SAR is nothing but this takes into consideration some beta into I as well as gamma factor here. So we use a model where this beta is nothing but the effective contact rate, which assumes to be 1 per minute, and gamma refers to the recovery. Here it's added with the mortality rate also, which is assumed to be 1 per minute. Now, in this SAR model, we follow a ordinary differential equation form where this S has got minus n inverse beta into Si, that is S into I. And with respect to I, we have this di by dt. Everything is with respect to time. As I told you, this is time series data. So it is n raised to the power minus 1 beta Si minus gamma I. And of course, the last one, that is the recovered one, is nothing but gamma into I. Now, what is this n? That's very important. So n is nothing but it is S plus I plus R. Okay. So it is the total population where and the T stands for the elapsed time. Okay. Now there is another model, as I told you at the start. We'll be discussing 2 models, and then the one is the SAR model. The second model is about SIRF with exposed waiting cases. So what is this F? What is this waiting cases, right? So here, SIR, I think I have already introduced what is SIR. Now let's just move on to what is this F. Here, this F refers to fatal with confirmation. Okay, I'll just explain one by one. Next one is this. What is this exposed waiting? Okay, so this is of very much interest to us. I think kindly mute all of you, the participants, kindly mute your microphone. Yeah, okay. So thank you. So here this S stands for susceptible, and here this exposed waiting. 2 terms are newly expressed here. One is exposed, which is nothing but they are exposed, but they are in the latent period, which means that without any infection. Okay, then what is this W? So I told you exposed waiting, right? Then what is the meaning for this W? Here, this W stands for the waiting cases for confirmation with infectivity. That is, we have been infected. So this is the second model, which we call it as the exposed waiting model. And here we have S asterisk, which is nothing but confirmed and uncategorized. Okay, they are not categorized whether they are fully infected or not, right? And the most important thing is another one I here, that is confirmed and categorized as infected. Okay, and finally we have recovered. Now let's go on and just see how it works. Here the total population, the measurable variables for total population minus the confirmed cases, which is nothing but S plus E plus W. I have introduced what is S, E, W and S asterisk earlier. And the number of confirmed cases is calculated by I plus R plus F. They're recovered with R, and the number of deaths are F. So the model works like this, you have here the formula for that. So we just move on with each and everything. So what is this alpha 1, alpha 2, beta 1, beta 2, beta 3? We have up to 3, and what is this gamma, right? So here alpha 1 refers to the mortality rates, that is the cases are negative. Next one alpha 2, so the mortality rate, that is 1 case per minute. And beta 1 represents the exposure rate of a particular person and assuming to be 1 per minute. And then beta 2 is nothing but the inverse latent period. I said what is the latent period earlier. And we have beta 3, which is nothing but the waiting time. And finally, we have gamma, which is nothing but the recovery rate. So we have some ordinary differential equations for all these terms like S, E, W, I, R, and F. So this model, as I told you, is nothing but, you can see here, just a minute, yeah. So SIRF with exposed waiting cases, right? So EW, SIRF EW. So we have for all the formula for all these things. So probably you can have a look at that later because we are just running out of time. Now let's go for some visualization in the presentation as well, and then we'll just move. I'll just show some code snippets for you, right? So actually, this particular data is calculated up to some 17, that is up to yesterday. So these are the infected number of persons in India. Okay, something nearing 50,000 plus, and we have the fatality rate around something maybe around 3,000 here, and recovered number of cases. You can see that the number of recoveries also gets increased, right? So which is a positive aspect as far as India is concerned. So here is a chart. I just copied that from my tool. Why? Because it takes more time to run and get the results because it calculates everything by online. So as of 16th May 2020, the fatalities that were expected or something around 2,871 recovered cases were there and infected with something like that. Okay, this is about some data. Now, let's go for the regression model by which we use the SAR model and what is the actual, how India is actually performing. So you can see that it's a linear curve, linear straight line here. Okay, so this particular line represents the regression model, and you can see that almost up to this particular time. Okay, so we are almost predictable, whereas now actually it's just moving away from us. That is, the number of cases is increasing. And this particular y-axis refers to the number of persons in India currently, right? Now, this is the next one actually. Here, what we do is we just split the graph into three. One is the initial phase. This particular column refers the initial phase. And this marks the end of the second phase, first phase, and this is the second phase. See now, you can see that the predicted value and the actual graph were very much closer on the initial stages. Okay, so of course in the first phase also it was nearly on that line, no major changes. But here you can see that it was online. There's a slight dip and just it's moving away now, right? So some changes are happening rapidly here. And the next thing is, this is a two things are here. One is observed and another one is the actual parameter. So you can see that it's calculated from, I think, 5th May. Okay, so 6th May up to yesterday, that is 7th May. You can see that there is a slight deviation, but anyway, errors will always be there, and we can compute that errors and try to find a model which more accurately fits into it. Okay, this is a second pattern. Of course, no major changes in it. I'll just skip it off. Now, this is another thing which includes the fatality rate, that is how many deceased and how many were recovered and how many infected. So you can see the graph. This is an India-specific graph, and you can see based on the population. See here, these two curves are really interesting to watch. You can see that it is growing, and also the recovered persons are also more similar to that, which makes that the number of infected person count is less. And see, you can also see a slow but steady increase in this particular fact. That is the disease rate. It's getting increased day by day. Okay, so this is just a table of that particular data, which you can see later. So that previous graph was in a week. That is, it was calculated based on a 7-day average. And here, let's take a 30-day value. And a 30-day value is quite the same thing, but you can see that this gap is quite less, right? So it's predicting something for up to July first week. You can see here. The issue here is that you can see that this is actually May, where we are now, and it's increasing, right? As per the forecasting, I'm just not saying that it will be like that. Based on our models, it shows that it's doing like this. But good news is that the fatality rate is not that much increasing as that of the number of infected and recovered cases here. Okay, this shows the data for that. And a long-term projection, what will happen based on this SAR, what is the long-term projection? So you see that almost it just moves on here, something like that. See, okay, sorry. This is, you can see that the graph is somewhat stable here up to this. We are almost in the 7th month, another 3 months, 8, 9, up to that, up to October, it's there, and it starts slowly residing. That is the number of susceptible cases. So you can see that the number of infected persons also here, you can see there is a hike again. Okay. So everyone is saying that it will get over by another 2 or 3 weeks. But as per the prediction models, you can see that again in 2021 there will be a hike. Okay, I am not saying that 100% will be there, but the model predicts that there will be hike there, and of course it will from the 7th month of 2021 it will just die down. That is, the infected persons will not be there. But anyway, fatalities will be there, but it's steady actually. Okay, we are lucky that the number of persons who are getting who are what is it, who died due to this pandemic is less in India, right? So it will be there. Okay, so here you see that the recovered rate is quite high. Okay, so which is a very good sign, which reduces the fatality rate. Okay, so let's just come to a conclusion of this particular presentation. I'd like to thank particularly Liz Freire, who was very much instrumental for me in designing this model actually. So he is the one who has designed this model. And I also thank Shamika Ravi, and I have extensively used in this presentation the visuals of her. Okay, so the first part, as I told you, will just conclude this particular presentation. Yeah. So the next thing will be a speech given by Mr. Ganesh Belgur. He is our alumni. He has completed his BTech Computer Science and Engineering from Amrita School of Engineering, Bengaluru. And he was a former computer graphics developer in MP Switzerland. And he will be talking about the advances in computer graphics and machine learning, reshaping the future of media. Okay. So, but before that, only one of my session is over. The second one, let's just conclude it in a what is it, very fast manner. So I'll just close this presentation and move on to my. I'll just move on to my demo. Please wait. I'll just share my.
In the meantime, if you have any questions, please raise your hand.
Okay. Can you see the screen now? My screen?
Yes, sir. Yes.
Okay. Okay. So actually, I don't want to take much time here in this presentation part and all. I just want to highlight few, 2 or 3 important things. Actually, I planned for more, but due to the time constraint, I'll just wind up. So as I told you, data is obtained in real time from the CSSC website, that is from Johns Hopkins University. So 3 data sets are used here. One is the confirmed global CSV data set. Another one is death global CSV data set, and the third one is recovered global CSV data set. So actually, if I run this particular code, I think it will give you the what is it, abstract of how much, what is the shape of this particular data set that is presently in use. Okay, let it do that work, but let's move on to the other thing. Now, so as I told you, this particular presentation is just to show you some visualization of how things are done. So I'm just downloading the data set. I'm printing some tail and head in the sense part 5 data are printed here. But let's go for the visualization part here. So this particular data is taken, and it is up to the current date, that is up to 17th May. Okay, so it is report confirmed cases across countries like China, US, Italy, France, Spain, and Australia. So here, how visualization is done. So it's nothing but we use a time series plot here. So we plot that by using this plot method. Okay, so here we use Seaborn, Matplotlib, Pandas, and NumPy libraries here. Okay, so this is about the confirmed cases across, and across the same 5 countries. Okay, we have just plotted, sorry, 6 countries about the deaths that has occurred. See, actually, in time series data, visualization plays a major role, right? Why? Because instead of just keeping some numbers and looking and gazing at that, we can have, or we can represent that visually, and which will give you a clear picture of how things are happening and how things are moving across. You can see that China, the flat curve is there, which means that almost they have recovered. Similarly, Australia, the case is there. Whereas you can see US, just that purple color, which is what is it, growing at an alarming pace. So see, this is a ordinary plot, and also if you want to see that in a logarithmic way, you can see this. This is the logarithmic representation of the same thing. Okay, so this is all about other countries. Now let's just come to our country, India. So I'll just show you. Okay, yeah. So this particular thing is about the confirmed cases that is in India. So it is up to some 15th or 16th May, I think 17th May. You can see that the number of cases here was something, it's nearing 1 lakh mark. That is 1 lakh mark, it's just nearing that. So the same thing has been represented by using a logarithmic time series here. Okay, so this is the confirmed cases. So also we can plot India's the death case that has occurred across India. See, I have just compiled all those things and made it ready so that it won't take much time here. So this is the death rate, and almost we have crossed 3,000 mark, right? Yeah, I think we have crossed the 3,000 mark here, and this is the logarithmic representation of each same. So, and okay,
sir,
I
I
just
think
want
we
to
are
conclude.
lagging by time, sir. Maybe quickly
Yes,
10 minutes, sir.
yeah, I'm just concluding my presentation. This is my last plot.
Okay, sir.
Which, yeah. So we are using one library here, which is called as Altair. So what is the interesting thing here? See, this is a very much interactive way of visualization. See, probably if I just keep here, it shows that US, the 68th day, it has got the number of cases, something like 89,562. As I just scroll down the line, I can see that 62nd day, it had a cases like 80,000. So I can just visualize something like that. On 43rd day, the US had 47,417, 12 cases. So as of India is concerned, India is here. So the 49th day, that is 49th day in the sense from the first day of reporting the casualty, as of now it is 30,025. So I can scroll down a bit and see how things are performed. So on the 47th day, that is 2 days back, it was 27,000. So I can scroll down the map and see how India is performing, right? So it was 1,637 days. So in 12 days, we have reported some 1,600 days. Okay, 600 days. So it has doubled in just 12 days here. Why? Because 37 it is 1,600, whereas here in the 49th day it is 3,000. So this is a very interesting thing that is Altair, which you can download and you can install in your systems, which will show you a very nice graphical representation. So I'll just stop sharing my screen. So dear all, I think this is all from me. Thank you all for being a patient listener.
So we have a question from Mr. Vamshinath. Can we take over the questions?
Yeah, sure.
Yeah.
Sir, hello, sir.
Yes, sir. Tell me, sir.
Hello.
Yeah, tell me,
sir.
sir.
In this particular model, how to find out this R naught, sir? What is the current R naught for our country?
So it is used as 0.14, sir. I'll share the PPT, and I think it is there in that. Since due to lack of time, I'm not able to explain much.
Okay, sir. Thank you, sir.
Yeah. Okay, ma'am. Shall I wind up? Is there any other queries?
We can take up the queries at the last. We have a question answer session.
Okay, ma'am. So thank you all for being a patient listener here. Thank you again. I hope that you all will enjoy the another speaker, Mr. Ganesh. I just hand over the session to him. Thank you.
Ganesh, I think you're on mute. Please unmute yourself.
Okay. Thank you. Are you able to hear me now?
Yeah.
Yeah, sure. Okay. Okay. Just a second. I'll load up my presentation here. So is my presentation visible?
Yes, it's visible.
Yeah. Okay. Thank you. So good evening. Welcome to my presentation on advances in computer graphics and machine learning and how they are reshaping the future of media and entertainment industry. My name is Ganesh, and I was a former computer graphics software developer at MPC Film, a subsidiary of Technicolor SA. I am an alumnus student of Amrita, and I graduated in 2016 with my bachelor's in computer science and engineering. So MPC is a multinational studio that provides post-production services to high-end Hollywood movies. The studio is capable of generating visuals that we have seen in movies such as Jurassic Park, Avatar, and other CGI intense movies. When I say CGI, I mean computer-generated imagery. During my time at MPC Film, I had the opportunity to work on multiple film titles and received on-screen credits. The highlight of my work was an application that enabled artists to procedurally generate fur, hair, and grass, which were used in movies such as The Lion King and Sonic the Hedgehog. The films were released in 2019 and early 2020, respectively. To give you a brief overview of what you can expect from this presentation, I'll be giving a very, very tiny introduction, explaining how machine learning has become vital in the development of some of these existing and upcoming techniques in computer graphics. So visual effects or VFX refers to the use of computer graphics to aid live action footages. A VFX company can ingest several thousand raw footages shot on set and to finally deliver the footages with various CGI elements added to them as per the director's vision. The footage that you see here is from the Lion King movie. The animals, the terrain, the sky, the rocks, the foliage, everything was created using the computer graphics technologies. A technique known as ray tracing has enabled artists to create lifelike photorealistic images that you see here by using just the limited resources available within a computer. The easiest way to think of ray tracing is to see that the objects around you are illuminated by beams of light. These beams of light bounce around tens and hundreds of times before finally reaching your eyes. That's ray tracing in essence, and as you can probably estimate, the process is computation really intense for a computer. Turnaround times are short in VFX companies. So with tight deadlines, machine learning algorithms are like cutting down hundreds of hours of labor-intense workflows in two specific areas that I'm about to show you now. So in this footage from the Jurassic Park movie, initially only the actor and the background were shot on set. But in the final footage, somehow the artists managed to add the dinosaurs and place them behind the silhouette of the actor in the foreground from the audience's perspective. So this process is called rotoscopy, and we are going to explore how rotoscopy is used in rotoscopy and machine learning work together. So here you can see that dinosaurs are kind of being placed on top of the actor initially, and then they fix it, and the actor actually comes in the foreground, and the dinosaurs go behind. So the ability to add CG elements in this way involves a technique called rotoscopy, as I said. So it is a painstaking process of making frame-by-frame cutouts of actors in a video to integrate the footage with the computer graphics element. As you can imagine, it's a labor-intense job and requires hundreds of artists making these cutouts for each individual shots like the one that we just saw. So semantic segmentation with models like DeepLab v3 Plus from Google has become popular in the recent times to make these cutouts for us. In fact, self-driving cars use similar techniques to judge whether they're about to hit a person crossing the road or simply about to go over a pile of rock or like a tumbleweed rolling on the road or something like that. So finally, the artists put the background, the dinosaur, the person, and compose the shot using a process called compositing. So that's how semantic segmentation area in computer vision has become really popular in the recent times. Okay, so sometimes a VFX shot may require artificial dust and debris to be added during the post-production step. For example, as the CG dinosaurs run on the forest floor in the shot, we expect to see some subtle amounts of dust and debris to fly around at the feet of the dinosaurs. We're going to play the shot again so that you can see the subtle amount of dust flying up into the air. And also there's some debris. Okay. So the FX department within a visual effects company is tasked with such challenges, and they use softwares which run heavy particle simulations. The popularly used Navier-Stokes equation has to be solved to get lifelike fluid simulations such as the one that you see on the screen here. However, for visual effects, we do not really need scientifically accurate simulations. Even if the simulations are really close to being perfect, they will be enough to trick the audience. So in the Navier-Stokes equation that you see here, the value you vector, the pressure, and the rho symbol is the kinematic velocity. The delta square symbol is the Laplacian operator. So people who are from mechanical engineering background, if there are anyone in the audience, probably will be able to relate to this equation. So fluid simulations are generally solved using a technique called material point method, or MPM in short. So to give you a very vague and an idea of how the technique works, we basically break the simulation space into a grid. At each intersection point on the grid, we solve the Navier-Stokes equation and interpolate those values across the grid. The particle's position is computed with these interpolated values, and we finally go back to the grid position to start the next cycles of solving the equation. A neural network can be thought to estimate and predict the Navier-Stokes values at the various grid points and basically carry on the cycle of computing the particle state and the Navier-Stokes value as predicted by the neural network. This is how we simulate fluids without ever solving the Navier-Stokes equation. Of course, the network wouldn't create a physical, but gets really close to it. Introduction to gaming industry and some application of in that industry. So the gaming industry has evolved considerably over the past decade, and the gaming companies that had heavily relied on rasterization techniques is slowly adopting ray tracing techniques that I talked about earlier. And there are some companies utilizing approaches, and they are called as hybrid rendering techniques. Unreal and Unity game engine creating games for mobiles as well as the desktop. The gaming heavily reliant on machine learning techniques that dates back to the time before the advent of deep neural networks. So here I'm about to talk about deep learned supersampling, or DLSS. DLSS is the ability to scale up an image without losing quality, and it has become the new norm to render real-time 4K videos at 30 to 90 frames per second. The game engine would spend time only rendering frames at 1080p or 1440p in resolution, and this dynamically gets upsampled to 4K resolution during the gameplay on the fly. If a game engine is made to directly render frames at 4K resolution in frame rate and struggles to even produce images that are sharp. With DLSS, the frame rate improves and the frames look much crisper. As you can see on the left here, there's no DLSS, and the game engine is directly trying to render the frame at 4K and 36. And on the right, DLSS is applied and the frame rates are 61 and the images actually look much more crisper. So I'll give you a very brief like the background of how deep learned supersampling works. A game engine generates an aliased frame at 1080p or 1440p very quickly, and then this is fed to a neural network which extracts vital features for making the image appear to look sharp at even 4K resolution. There's a lot of research going on into finding good loss functions for these neural are extracted to create the final anti-aliased 4K resolution frame for the game player. So that's a very, very simple and a layman explanation for supersampling with deep learning. The next application is the ability to predict. I'm sorry? Can you please mute? I can hear my own voice. It's a bit, okay, sorry, thank you. I'm going to replay this video. The next application is the ability to predict the movement of a game character on a complex terrain. Since it is not practical for human controls to adjust the position of the feet for the game character who just climbed that small cliff, reinforcement learning techniques are used here. She instinctively places her right hand on the floor as she walks through, and such subtle effects convey the character's curiosity to the player. So the technology behind adaptive motion of game characters is taken from robotics, which heavily relied on reinforcement learning techniques to teach robots to walk and run. The robots from Boston Dynamics are a good example for that. And I'm going to briefly explain what reinforcement learning is here. So it is a way of mimicking the process of how a human child would learn. It's by trial and error, basically. As you can see here, these bipeds struggle to overcome the obstacles, but eventually figure out a way even though their motion looks really fuzzy and haphazard. In the video of the character climbing the cliff that we saw earlier, the game engine actually uses a combination of recurrent neural network and a deep learning network to predict and make intelligent guesses for the character. So that's how she's able to place the right hand instinctively on that door, as any human would actually do. The model can actually detect incorrect motion, such as slipping off the cliff in the previous video, using the parameters from the physics engine, which is inside the game engine itself. Yet another application of reinforcement learning in gaming is making the game bots better as they play with the human players over time. The bots in the images here are on the right, and you can notice they initially struggle to even understand how games are supposed to be played. The reinforcement model is basically adjusting its techniques in each iteration of the gameplay and trying to maximize its rewards, which is nothing but the points on the scoreboard here. If you have noticed, especially on the image on the right, you will know that the bot player on the right initially performs poorly, but eventually ends up beating the human player with a score of 22-17. But yeah, you can see that it's going to, starting from now, it's going to continue till 20. And it's going to eventually win. And moving forward, this is a new application. It's called deepfakes. So deepfakes have taken over the internet these days. It's a process in which a person in an existing image or video is replaced with someone else. The person's video is I'm sorry, I can hear again. Can someone please mute their mics? I'm sorry, okay. The person's video in the center is the source video, and he's able to make powerful people say things that even make a statue speak, which is rather funny, but it's kind of dangerous, which I'm about to explain now. So, of course, the person has to be able to people to make the videos more convincing. A recent research paper on human voice has been able to convert a person's voice to sound like any other person's voice. And with these two technologies combined, people are generating videos where they're able to place words into powerful people's mouths. So you can sway huge groups of people and give them misleading information. So this is a very dangerous technology and also exciting for researchers in computer graphics and machine learning in particular. Security researchers are finding ways to counter these techniques and detect fake videos before they become viral so that they can be taken down. So there's this arms race between security researchers and rogue deepfake filmmakers to find algorithms that are not vulnerable to attacks. If anyone has heard one pixel attack on image detection models, you'll probably know how this arms race is turning out to be. And of course, starting from now, you should be careful about those WhatsApp forwards that you get with politicians making really weird claims that is too good to be true. So in those cases, it's better to fact check before you actually believe what you're seeing, because deepfakes is a new norm now. So using deepfakes involves extracting a 3D face masks from both the input as well as the target video clips. And these 3D face masks are given to a generative adversarial network, or GANs, which does the facial feature transfer from the source mask to the target mask. So generative adversarial networks have a transferring process perfect and a discriminator network telling the generator network whether the features that were transferred are good enough. Basically, the generator creates a fake video clip and discriminator tells whether it actually looks fake or not. When the discriminator fails to tell that a video is fake, the generator network has won. And that's how we get really photorealistic deepfakes. All right. That's mostly about the applications of machine learning in computer graphics. So computer graphics isn't a perfect mimicry of nature, but as the hardware technology improves, we aim to be more physically accurate because we have more resources to run the physically accurate algorithms. Finally, to conclude, machine learning is still a very new tool in computer graphics. The industry is taking baby steps with it, and the techniques like deepfake may seem dangerous at first, but there are some interesting applications in dubbing of movies apart from performance capture. Some of the techniques that I've described here were published as latest as 6 months back, so it's really an exciting time to be alive if you're a computer graphics or a machine learning researcher. Further, please take a look at the reference section of this presentation to find the papers describing these techniques in detail. So don't forget to take a look at these references. I've put all the papers here so that people in the audience can finally go through the papers when they have time. So I can take some Q&As now. Since we're running out of time, maybe just one or two questions, I guess.
You guys can put your questions in the chat box. Or you can raise your hands. Anything is fine.
Since I'll not be able to see the chat box, just tell me the question.
I will read it out to you if I get the question.
Ganesh, do I have to play the entire video with sound? You were asking.
Sorry?
Do I have to play the entire video with sound? You were asking me, no? Initially.
So if there are no more questions, can we move on to the next session?
Yeah.
I'll just give a brief introduction to the next. We have Mr. Apurva Anand. He's an MTech alumni who got an opportunity to do a dual degree program at L'Aquila University in Italy. He started pursuing his PhD at the same university. So over to Mr. Apurva Anand now.
Hello. Yeah. Can you hear me?
Yes, Apurvanand.
Okay. Thank you, ma'am. Thank you, Ganesh. Good evening, respected professors, alumni, and students. As Ganesh said, I'm a PhD student from L'Aquila University, Italy. And my PhD is based on European funded, and it is in the area of model driven engineering. I joined Amrita Vishwavidyapeetham School of Engineering in Bangalore campus as a GATE qualified student for MTech in CSE, and I have got an opportunity to work in research papers in the area of algorithm and machine learning in Amrita. So my inclination for research has been budded in Amrita only. So as there are various foreign collaboration opportunities, such as foreign exchange programs or dual degree program in Amrita, I applied for dual degree program where I got admitted to L'Aquila University in Italy. So I'm happy to say that I got 2 degrees in 2 years, one MTech from Amrita and another MS from L'Aquila University. And it is in the area of Informatica. So they call it as computer technologies. So getting 2 degrees from 2 countries, and that too from one from India and one from a European state, European country, it means that one has a greater chance to apply for a job, or in my case, in research in the whole of European Union country, as well as in India. So after my master degree, I have 10 months of research experience in Amrita University only from Coimbatore campus, followed by CSIR CD laboratory in Rajasthan. So my dual degree program, which is facilitated by Amrita University, enables me to get into my PhD in L'Aquila University and started a career as a researcher. So I'm happy to connect with you and thank you. And like any queries regarding dual degree programs or getting abroad and study there, it's most welcome. And I'm happy to help. Thanks.
So as the last session, we will have a demo based on the debugging skills of a learner by Ms. Chandrika, scientist at ABB Bangalore. Over to you, Chandrika. And thanks to Mr. Apurvanand Sahai for your time.
Thank you, madam.
Yeah, thank you, Nalini, madam. In the interest of time, I'll just give you an introduction of what of myself, and then on the debugging skill model, what we are just going to demonstrate. So I did my master's in computer science engineering in Amrita, and thanks to the excellent support from the faculty members and the corporate relations in Amrita, I was offered an internship with Intel, where I worked on the mobile communication research. And since my aspirations were to become a researcher, I came back to Amrita for the doctoral program under the guidance of Dr. Amuda. And I also received an internship program with the ABB Corporate Research, which is one of them across the globe. And I joined there as a usability researcher, and as a full-time employee. So I thank Amrita University for their continuous support. So without much delay, I'll just demonstrate you what we have done. So somebody was asking how you have collected data. So we have used most of the open source tools to collect data. So ma'am has already explained to you that we use something called as night tracker to collect where the gaze of the learner is. And then we use something called as Nogama. Are you able to see my screen?
Yeah, yes, ma'am, we can see the screen. Yeah.
Okay, so we have this tool, open source tool, which will help you to record the eye movements of the learner. And if you can see, this is what ma'am has demonstrated to you, that we had given a program, and then we have something called the yellow dot says that this is where the person has gazed. And this raw data was then processed for the dwell time. And so I'll be demonstrating you this particular use case where you have a learner who was debugging the program, and where his dwell time is very high and the bugs detected were also very high, and then his skill was being predicted as the skilled learner, the debugging skill as skilled. So this is what I'm going to demonstrate now. So here we have used the intelligence system as the fuzzy inference system. So the fuzzy inference system has three major sections. That first is you define the variables, and the second is the you define the activation methods, and then you do the declassification. So we have used the open source tools for this. We have used the Scikit fuzzy package from the Python for this demonstration. So you can see here that I have defined two independent variables called as error, that is the number of bugs identified by the learner, and the dwell time, that is the time he has gazed in that error region. And then this skill is my dependent variable, that is the predicted value. And then I define what are these variables. I define the low, the medium, and the high range of each. And then you can have a visualization of this. So you can see what are the ranges of this. So this being the low, the blue being the low, the green being the medium, and the red being the high value. So the same thing applies for error, dwell, and the skill. And when we are doing an activation function, we also, fuzzy inference system requires some kind of rules to say, define the rules for the prediction. So I have defined few rules for the interest of this webinar. I have just defined 4 rules. So first I say that if the dwell time is very high and the error identification is also high, then I am a skilled learner. So this rule was being learned, and I just defined for the interest that I have a high dwell time here, and my errors are 2 errors are being identified. So I define those input values here, and once I do the activation, apply the activation function. So I apply the activation function here, and then I aggregate the results. It predicts. So you can see the visualization here. So it has predicted that the learner is a skilled learner. So this means it's a skilled learner. So this is what you can see here. The more information on this can be found in our research paper, which has been published in the Journal of Intelligent and Fuzzy Systems. The paper is on fuzzy intelligence system for eye movements data. So now over to you for any questions. So you can ask questions to anyone, from Amada ma'am to President Kumar sir, or to Ganesh, or to myself.
Okay.
By Ms. Mihika. You can unmute yourself.
Hello. Hello.
Yeah, Mihika.
We can hear you.
Yeah, I had a doubt to Mr. Ganesh. How did you get a jump start into this career field from like your BTech days?
So thank you for that question. So during my BTech days itself, I was like really interested in computer graphics, and I had been looking for opportunities in gaming as well as in visual effects companies. So it's a very new area, and only few companies have come to India so far, and MPC is one of them. There are also a few more companies there, but I can probably talk about them later. But yeah, so I was always looking out for these opportunities, and I was learning about visual effects and gaming while I was doing my BTech itself on the sidelines. So that's how I got to apply and get a job there.
Okay, thank you.
Yeah.
Yeah, Aditya,
Okay.
you slide. So all the participant, hope you would have filled the feedback form. Suppose if you didn't fill the feedback form, please fill it. Okay, and I would like to thank all the participants for finding the time and attend this webinar, and hope the session Explore Insights into Data was interesting and informative. And again, we have some more webinars from 19, that is from tomorrow to 22nd at 4 to 5:30 p.m. So we look forward to seeing you all the next events, next webinars. So the webinar links are shared in the chat box. Please register if you're interested. And I would like to thank the other people for behind the show, that is the faculty organizers, Jyotsna and Nalini ma'am. Again, the student organizers, Aditya, Ashwin, and Ritvik Lal. They were from the beginning helping to organize the webinars. So thanks to all the participants. And again, I would like to thank all the speakers also. Thank you, Amuda ma'am. Thank you, Prasanuma sir. Thank you, Chandrika. Thank you, Ganesh. And
Thank you,
thank
ma'am.
you,
Yeah.
Mana.
Thanks to you,
Thanks.
Jyotsna.
Yeah, thank you. Thanks to the organizer. Thank you to everyone. Thanks for joining the session. Looking forward to see
thank
you
you
all
all.
in the next upcoming session. Thank you.
Thank you.
Let's conclude.
You can show the poster of next webinar maybe. You can show the poster of next webinar, Radha.
Yes, ma'am.
So if anyone interested to join for this webinar, please fill the Google form. Again, it's given, the link is shared in the chat box.
I think somebody is asking for a link.
We shared in chat.
I don't know. You can see in the chat only.
All the links has been shared, no, Aditya?
Yes.
Yeah. No, it's okay.